Welcome to ECE 3270. This is Introduction to PLC Programming, Lecture 8. Today we're going to be talking about actually something that is only tangentially related to PLCs, in that this is an application that you could put PLCs into. And the reason we're going to do this is because this is going to introduce the lab that is coming up in the following weeks, and it's important that you have a pretty solid idea of exactly what it is you're trying to program. So there will be obviously a lab manual to go along with it, but this video will help you to further understand exactly what these pneumatic road tubes or pressure road tubes are intended to do and how they work. So here we see an image of a pressure road tube system being used to count traffic. So what we have here is, this is a road, obviously, and we have some large vehicle that is coming down the road. And as they run over this tube, the air pressure in the tube will increase. So as the vehicle crushes the tube, the volume in the tube goes down, which makes the pressure in this road tube go up. And there's a pressure sensor in here that detects the increase in pressure that is caused by the wheels of a vehicle running over the tube. So it's pretty easy to detect that someone has ran over the tube. And then over here there's a second one, so that when the wheels hit this tube, they know how long it took to go from point A to point B. And if you know how far apart that is, and you know how long it took, you can easily know how fast they were going. So this helps in a lot of ways. So specifically, this is used for traffic counting, for planning, city planning, things like that. So civil engineering typically would use traffic counters for city planning. But also, you could use these to check to see how fast people tend to drive on a specific road. So police forces could use these to analyze and see where it would be best to monitor the speed of traffic, things like that. So the road tube or traffic counter machines like this would be an ideal application for a PLC. So what's typically embedded in these is some sort of a microcontroller, and that works very well. But if you wanted to be able to make a pressure road tube machine and you didn't want to mass produce them and you wanted it to be customizable, a PLC would be an ideal application. A PLC would be ideal for that application. So what we're going to be doing in the coming lab is actually programming a PLC to work as a pressure road tube machine to do traffic counting and speed analysis, as well as average speed analysis. Now you're going to have two labs to be able to complete this. So I'm not going to give you the code, I'm not going to tell you how to do it per se, but we will discuss in some detail how they work so that we make sure that you know what's expected. So first of all, you're going to have to make the HMI and the code, both. So let's say we have a road here, and we have the yellow line down the road. Then somewhere along here, we've put our first pressure road tube, and it goes off to the controller. And here we put the second pressure road tube. It goes off over to the controller. So we have a car coming down the road. We drive on the left-hand side. So car coming down the road. Don't know what kind of car that is. It's a weird looking car, but whatever. So it's coming down the road. When it hits this tube, we begin to count how much time elapses until this tube is hit. So we're trying to measure how much time elapses between here, and here. So t equals question mark. So we need to know how much time elapses, and we need to know the distance. If we have time and distance, we can get speed, right? So this should be very straightforward. Time and distance. The way that you'll get the distance is someone's going to have to tell you how far apart it is. So this will have to be a setting on the HMI. So you'll have to have a field in the HMI to be able to have someone type in the separation distance between the tubes. Then you'll have to calculate how long it took for the car to go from tube 1 to tube 2. And that'll give you your time. And we've talked about ways of doing that, right? We've talked about instructions that we would use to answer the questions, how long has it been, and the question, has it been long enough? And so you'll have to decide which of those instructions to use and figure that out. That'll give you the speed. You're also going to have to keep track of just how many total cars go down this road. And one assumption that we're going to make is that only cars use this road. So only two-axle vehicles use this road. So this is an assumption. So you need to make sure that you understand what's happening here. We're saying we're going to not code this so that it can handle every possibility. We're not going to handle tractor trailers. We're not going to handle dually trucks that have potentially, three axles or something like that. We're not going to handle any of those situations. This machine is explicitly built to handle two-axis vehicles. And that's okay because that's what our customer wanted. They wanted a pneumatic road tube traffic counter system that would work for two-axle vehicles. So that's what we're going to provide. So we've talked about the distance of separation between tube 1 and tube 2 and how that affects the speed calculation and where you get that distance. We've talked about the time it takes to go from tube 1 to tube 2. And we've talked about that we're only going to handle two-axle vehicles. And we've talked about that this should count how many total vehicles have ran over the tubes. We need a reset button on the HMI to be able to reset the total cars counted and the average speed for a vehicle traveling down this road. So we need a reset button. Finally, the last thing we're going to need is we're going to need to keep track of, like I said, the average speed. Now, typically, how would you go about average, right? You'd have S1, S2, S3, right? And this equals what? 5. That's a really slow car. 15, still pretty slow. 35, a little bit faster. So then you would say S1 plus S2 plus S3 divided by 3, right? And you would wind up with 55 divided by 3, so somewhere around like 18. 18.33 repeating, something like that. However, that means that we're going to have to keep a history of every car that comes down this road. Okay, he was going 5 miles an hour. He was going 15 miles an hour. He was going 35 miles an hour. She was going 75 miles an hour. She was going 2 miles an hour. She was doing the speed limit. So in order to do that, it sounds like we're going to need a history of every car that has ever gone down the road. But that's not a good solution. That's not a good way to go about this. And I'm not going to give you the solution to this, but here's what I'm going to say. However you keep track of the average, it should only need these things: current count, so the current number of vehicles that have gone down the road, the current average speed, and the new speed. So we have some current average speed, and another car comes down the road and runs over the tubes. Now we have a new speed. Given the current number of vehicles that have gone down the road, the current average speed, and this new speed, you should be able to calculate from that the new average. And this is the way that you should go about it, because if you attempt to create a history of every vehicle that has gone down this road, that's possible and readily doable. There's a lot of memory in a PLC, but if it was a very busy road, that could take up a lot of memory. Also, you don't know how yet, most of you probably don't anyway, know how to create some sort of a history like that in a PLC. So that wouldn't be a good solution anyway. So instead, think about how to do this using the current count, the current average speed, and whatever the new speed of this newest car is. Figure out what the new average speed should be. So that's sort of a broad overview of what the lab's going to be about. I like this because you see these all the time. You see these black strips over the road, you run over them, you hear the thud, but you may not know what they do. So what they do is traffic count and monitor average speed on the road. And this is a great application if you were going to make a customizable version of a pressure road tube or pneumatic road tube traffic counter. It's a great application for a PLC. So that's the introduction for this lab. And as promised, this is going to be a shorter lecture than usual to make up for some of the longer lectures that we had in the beginning.